Hello, good day. Welcome back to my channel. Today we are talking about predictive parsers, and we'll be looking at a few things. We would consider how to actually read a string. Then in another video, we'll consider how to construct the parsing table. But we are going to look at what a predictive parser is, and we're going to check out how to read an input with the predictive parser. So what exactly is a predictive parser? A predictive parser is simply an efficient way of implementing a recursive descent parser. Recursive descent parsers. We know these guys are the guys that actually don't need um, they don't need backtracking. They don't need to do backtracking. I know backtracking is just more about dealing with having to read an input repeatedly while testing the different ways the input can go in derivation. So predictive parsers don't need backtracking, and that's because they're implementing the recursive descent parsing method, and they use the stack. They handle it with stack also. So this is how they look like. I'll just draw a rough diagram. So this is the input buffer. It has a right end marker, which is the dollar sign. It has, let's say there's an input a plus b, then the program that does the parsing, the predictive parser program. Then there's a stack, pardon my drawing, which contains, you remember what I said about x, y, z, right? X, y, z. Then you know that when I say this big x, y, z, they are grammar symbols. So they could be non-terminals and they could be terminals at the same time. All right. So there is also a parsing table, and we're going to consider how to do that in another video. And there is the output. Then this parser, the parsing program would come to this input buffer, and also take from the stack. So it's going to perform operations based on these three things. It has an input, a stack, and a passing table, and then it gives an output. So the input contains a string, let's say id plus id star id, a string of terminals. That's what will be in the input. And then I've mentioned the dollar sign, which is the right end marker for the input, but the stack also has a bottom marker. And this parsing table, which the predictive parser program also look at, has a set of entries that is a two-dimensional array, basically 2D array consisting of non-terminals and terminals, structured such like M, which is the table, now has entries A, which stands for the non-terminals, and then A of lowercase a, which is for the terminals. So the entries of the predictive table consists of terminals and non-terminals, which are structured in a table so that you are reading through the tables to choose or to decide which way to go. So I'm going to move on quickly to how this stuff works. Remember that the previous ones we dealt with were bottom up parsers, right? So what they were dealing with was reducing, but we are not reducing here. We are deriving. So I'm just going to deal with their operations, and then I'll go straight to an example. I believe, yes, I'll deal with an example after that. So what do we have? Number one, this is how the program works. The program, let's just talk about actions. So number one, if x is equal to a, and that is equal to the dollar sign, what are we going to do? We are going to halt the program. The parser will halt. So halt, and then announce success. Announce success. Everybody pops the champagne. We all go woo, and we are done there. But then what happens if x derives, or x is equal to a, and that is not equal to the dollar sign? What do we do there? the parser will pop X from the stack and then shift the pointer on the input to the next input symbol. Then finally, no, not finally, the third one we have is if X is a non-terminal, we are going to have to check. We're going to have to check for the passing table. We are going to check the passing table. Remember, I talked about the passing table being a 2D array containing non-terminals and terminals. So now we are going to check for what X is. Since X is a non-terminal here, the A is usually the input symbol, and input symbols are always terminals. So we are going to check the passing table for X, which is the non-terminal, and A. We'll show how the passing the table looks like. We'll show how the table looks like. But for now, this is just what we are going to have to check the entry for this guy. There will be a unique box where this figure will be, and then whatever it is that we'll take will be a production. So maybe let's say X derives, since it's a non-terminal, maybe ABC or something like that. No, let's use, because grammar symbols, let's say XYZ, because it can be non-terminals and it can be terminals. So in the entry of the table, we'll have something like this. So how do we structure, or let's say UVW? I don't like the XYZ. UVW. Now we are going to have to push this on top of the stack. So push to top of stack, such that U will be on top of the stack. So it's going to be like this. It's going to be like the WVU. It's going to be like this, so that U will be on the top of the stack. Since we are writing the stack to look like this, WVU, and the right end is usually the top of the stack. I'm going to show you the predictive parser shortly, because in the predictive parser we actually decided to do something with the arrangement of the stack, so that we won't need to stress ourselves too much in writing. But just remember that if this is the production, U has to be on top of the stack, and then that's why it's in reverse like this. I'll show you how it looks like in the predictive parser when we get there. But just remember, when it finds a non-terminal that is not equal to A, then we have to check the passing table, and then we'll take the entry found where the box of MXA is, and then we are going to push that entry on top of the stack. And the top of the stack might have, might actually be empty, but just depending on what we have, not the top of the stack, the entry might be empty, but when we get to that bridge, we are going to cross it. But just remember that when it finds a non-terminal, it's going to take the non-terminal and the input symbol, and then check the passing table, and then push the entry to the top of the stack. Now finally, what do we do when MXA is an error? And what do we call errors here? The entries that are empty, when there's no nothing in the entry. The entry doesn't have anything. It doesn't have terminals. It doesn't have non-terminals. It's just blank. Then it's an error entry. And when the table gives us this, we have to then call for error recovery routine. So as a recap to all I just said, if the grammar symbol X is a terminal, and that terminal is the $sign, what do? We alt and announce success, because we've reached the right end marker. Now what if the grammar symbol X is equal to A, which is the A of the input symbol? What do? And it is not equal to the $sign. It means that we have not yet reached the end, and we have to do something. we are going to pop X from the stack and shift the pointer of the input symbol to the next input symbol. What happens when X is a non-terminal? We're going to have to check the parsing table for X and the input symbol, and then we are going to push the result on top of the stack, such that I'm going to show you how the reverse looks like. Then finally, if there's nothing on the entries, then we know that it's an error, and then it's going to kick off the error recovery routine. That is the activity of this parser. Now we are going to look at an example. Okay, so before we look at that, we have to draw out what the grammar looks like, and I'm going to write that out. E derives T E prime. E prime derives, and if you notice, this is a non-left recursive grammar that has been fixed. Then T derives Ft prime, and T prime derives star Ft prime and empty. Then F derives E in parentheses, then ID. Let me scale this down because we need more space. Okay, so we also need to do a table. So I'm just going to create this so that we can work well. So the passing table looks something like this. So we have the non-terminal containing E, E prime, T, T prime, and F. In the next videos, we are going to show how they actually work. So the input symbols, let's say ID plus star, open and close, and then the dollar sign. So pardon me for how it looks. My hand doesn't draw very well. Okay, so we have that, and the entries we have E derives T E prime, E derives T E prime. For this we have E prime derives plus T E prime, and then E prime derives empty, E prime derives empty. If you have the slides, you can just follow and use the slide instead. But I'm just trying to make this so that I won't have to be referring to something that is not on the screen. Okay, so star T derives star F T prime, and then derives empty here, derives empty here, derives empty here, and F derives ID, and F derives open. Okay, so now let's draw the parser. So we have matched, we have the stack, we have input, and then we have actions. Depending on the exam questions, you might have to draw these by yourselves. Okay, so let's say we have an input ID plus ID, ID plus ID star ID. So we are going to have to now for the stack, I was going to talk about that. The stack implementation, normally we usually have it at this end, right? But because of the structure of this particular parser, we are going to put the dollar sign here, and I'm going to show you why. Remember what I said about if there's an entry X derives UVW, we are going to put it on top of the stack, but with U on top of the stack. If we do this dollar sign here and they will say UVW, then U is actually at the bottom of the stack, then followed by V, and then W, which is supposed to be at the bottom, is on top of the stack. So we need to fix that. So I'm going to clean that up, and then I'm going to add UVW, then $sign to this point. So now which one is on top of the stack? U is on top of the stack, followed by V, followed by W, then this. So the arrangement is important. We have arranged it such that U is on top of the stack now, because the stack is at the other side. The end of the stack is at the other side. So we don't need to reverse by ourselves. It will be even more confusing if we have something like $sign WVU. It's going to be more confusing that way. So it's just better for us to do it like this. So what do we have? We have ID plus ID star ID. And then because we are not reducing, we have the root, which is the start symbol, and E in this case is the start symbol. What do? We don't have anything matched, but let's get started. In our table, recall that when we have a non-terminal, we are going to check the table for X, which is the non-terminal in this case, and the input symbol, which is ID. So on the table, what is E and ID? On M, E, and ID, we have E derives T, E prime. So what's the action going to be? We are going to move on to the next. So we are going to have T, E prime, right? So T, E prime $sign, because we have pushed this, we have replaced the E with T, E prime. So what's still on the input symbol? So we have the ID plus ID star ID $sign. And then what is the action that happened? We did an output of E derives T, E prime. Nothing is matched yet. Now, what is T ID? I'll clean this up. T ID on the table. So check here. T on ID is FT prime. So what do? FT prime replaces the T, but there is still E prime there, and then there's the $sign. Then ID plus ID star ID $sign. What do we do from here? We are going to write the output. What was the output? The output was T derives FT prime. Nothing matched yet. But then recall that the non-terminal and the input symbol will be checked again on the table. So I'm going to just do that here. So F and ID. So F and ID derives F derives ID. So what do? We replace F with ID. So we have ID, T prime, E prime, and $sign. Now ID plus ID star ID $sign. Recall what I said, and let me just write output F derives ID. Remember what I said earlier about X equals to A equals to not equal to $sign. I said we are going to pop X up and move the input symbol. So in us popping X is ID in this case. So we are going to in the matched entry table on the matched column, we're going to have ID because it has been matched. We are popping it off. So what is left? T prime, E prime, and $sign. And we have matched one ID, so we remove that. So we have plus ID star ID $sign. And what is the action? Matched ID. What next do we do? T prime and plus on the, because T prime is a non-terminal and plus is the input symbol. So what do we have here? Let's look at this. T prime on plus. Oh, I think I might have made an error somewhere. T prime on plus. T prime on plus is empty. So yes, I didn't make an error. So T prime on plus is empty. What do? We are going to pop it off. We're not popping it off. Since it's empty, we are turning it into empty. And how do you turn something to empty? By emptying it, of course. So plus ID star ID $sign. But output is what? T prime derives empty on plus. I didn't write that out properly. I should have just done that. Now, moving on, what do? We have e prime on plus. What is e prime on plus? E prime on plus, let's just check. E prime on plus. On e prime on plus, we have plus t e prime. So what do? We have plus t e prime dollar sign plus id star id dollar sign. What do we notice here? We have this guy is equal to this guy. And what do? We pop the identical one. But then let me complete what I was writing, which was output e prime derives plus t e prime. So popping this guy off, we now have id plus t e prime dollar sign id star id dollar sign. And then what's that? Matched plus. Now what next? We have t and we have id. So t and id. T and id ft prime. So what do we have? We have id plus here we have ft prime mt, no, e prime dollar sign, and we have id star id dollar sign here. Okay, so from here, what is the output? Output t derives ft prime. Okay, so what do we have next? We have f and we have id. On this we have f and id is going to give us f derives id. So what do we have here? We have id plus, then we have id t prime e prime dollar sign and id star id dollar sign here. Output f derives id. Now we notice that id and id here are identical, so we pop id off. So we have id plus id, then t prime e prime dollar sign. Then what do we have on this side? We have star id dollar sign, and what is that? Matched id. Now we have t prime and star. T prime and star. So what is t prime here and star on this place? We have star ft prime. So what do? We have id plus id, then star ft prime e prime dollar sign. Then we have star id dollar sign. What was that? We output t prime derives star ft prime. What next? We notice similarities again. What's the similarity? Star star. So we pop star out. So we have id plus id star, then ft prime e prime dollar sign. Then we have id left and then dollar sign. Note that okay, I'm just going to do matched star. What next? F and id on the entry table is f derives id. So id plus id star id plus id t prime e prime dollar sign, then id dollar sign. And then we have output is f derives id. So what next do? Id is matching id. So what do? We pop id out, id star id, and we have completed that. But we still have some non-terminals in this place, and then the dollar sign. All right, and then we have matched id. So I need to create a room, or maybe I should just clean up the top and start from the top. Clean up the top and start here. So I'll just say dot 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 dot. So since id plus id star id has been matched, what do we have next? We have t prime And now let's just say T prime on let's check the table again. T prime on dollar sign is what? T prime on dollar sign is empty. So what do? We pop, no, we're not popping it. We're just making it empty because that's what it is. So what are we left with? We're left with E prime, dollar sign, and dollar sign. Action, output, T prime is empty, derives empty. So what's next on the list? We have matched this guy out. So E prime on dollar sign, what do we have? E prime on dollar sign. It's also empty. So what do? We have dollar sign left and dollar sign here. Output E prime derives empty. Then since dollar sign and dollar sign is what's left, so remember what I said about that. X is equal to A equals to dollar sign. What do? We announce the successful completion of the passing. So we accept A. And then that is all. We have answered this question. But if you notice, we have not yet talked about how the hell do we generate a passing table. How do we do this guy? They are not just some miraculous constructs. Sometimes we have to make them by ourselves from the grammar. So in the next video, we'll be talking about this guy, this table here. So I'll see you all in the next class. Thanks for watching.